Lesson 5.3, Graphing and Interpreting Data and Measures of Variation. Before we talked about measures of center, now we're going to talk about what's called the spread of the data and how far from the center things are. To do things like that, we need to look at things like range. And that is the difference between the extremes of a data set, and by extremes I mean the maximum and the minimum. So when someone says it ranges from 10 to 30, that's one way to say it, but officially the range is a number and the difference of those two things. So instead of saying 10 to 30, you would say, well, let's see, the difference of 10 and 30 is 20. The range is 20 units. And that gives you an idea how spread out the data is. A box and whisker plot. It's a method for displaying the median, quartiles, and extremes of a data set. And a box and whisker plot uses median, and it cuts the data in half, and quartiles are medians of the lower and upper halves, and extremes again are maximum and minimums, and we'll show how we get those later. Interquartile range is the difference between the upper quartile and the lower quartile. So if you have values for those two things, you would subtract them and you would get the difference or range. 5-point summary are the numbers used to make a box and whisker plot, and you use the lower extreme and upper extreme, which are max and mins, the lower quartile, median, and upper quartile. And again, the median is the median of the whole set of numbers, the lower quartile is the median of the lower half, and the upper quartile is the median of the upper half. Standard deviation and variance are also a measure of spread. They are complicated formula to use. We're going to use our calculators for this as often as we can, but it does measure the spread by looking at how far the observations are from the mean. So in other words, how far does the data spread out from the average or the mean? And your calculators will give you standard deviation, but they do not give you variance. But variance is just the standard deviation squared. The reason they have standard deviation and variance is that variance is the unit of variance is squared, and it doesn't make much sense. So if you say the variation or the variance is like 2 units, the variance is in 2 units squared. So let's say we're talking about heartbeats, so 3 heartbeats squared doesn't make much sense to anybody. Well, let's say 4 heartbeats squared doesn't make much sense. So if you square root that 4 and get 2, then you would say the standard deviation is 2 heartbeats. So that makes more sense in discussion than heartbeats squared. That's harder to interpret. So let's look in box and whisker plots. Now here's an example that we can look at where we have data in order. The data happens to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Therefore 5 above, 5 below, and you have 2 middle numbers. These two are both in the middle. So therefore the median is the average of the 2 numbers. So the average of 31 and 33 is 32, and that's where this comes into play. And we always want to graph our box and whisker plot on a number line or above a number line so that we can accurately make the units even. So we have these tick marks that spread it out evenly. We just don't want to make a box and whisker and then put numbers there. We want it over a number line. So this is your median right there. When you have an even number of terms and you have this median cut the data in half, you will include the 31 in your lower half calculation for the median of the lower half. And that has 5 terms, so 29 is the median of the lower half, and put right here, which would be called Q1 then. So this is Q1, quartile 1. You have 5 in the upper half, 5 digits. The middle one is your median, so 35 represents your upper quartile. Quartile 3. And your median and quartile 2 represent the same thing, but we don't use quartile 2 for referencing. We call it median. And then you have your upper and lower half your max and min. And this would be your minimum, and this is your maximum. And that is a 5-point summary used to create a box and whisker plot. So the box is where your quartiles are, and then you connect them with the box. Your median is a line in the middle, and then these are your whiskers. Whisker 1, whisker 2. So let's look at an example. We have this list of data, 20 to be exact, give the 5-point summary of the data. Now we can put them all in order. If we do that, this is what it looks like. Alright, so if we count them, there's 20 of them, so if we go 10 on one side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's the average of those two. Okay, so that's your average. I'm going to get rid of that. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The average of these two, which is 2.5, that's going to be your median. It also cuts the data in half right there. Now when there's an even number of terms, the two numbers that are on either side of this line are included in the upper half and lower half. So you want the upper quartile, 1, 2, 3, 4, so there should be 10, right? So 5 in from each side, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. The average of those two will be the upper quartile, 1, 2, 3, 4, 5. The average of these two will be the lower quartile. And then your max, in other words, upper extreme, and your min, or lower extreme. Now I can get that, and if you look at that, then here's the information. 1 is your minimum. The average of those two, I have 2. I think I might have miswrote there. 1, 2, 3, 4, 5. Oops. If I count more carefully, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's between those two. So the average of those two is 2. Your median, 2.5. The average of these two is 3.75. Add them up, divide by 2. Then your upper extreme, or your maximum, is 5.5. If we graph those, we have minimum is $1, maximum is 5.5, median is 2.5, so I'll put a bar. Lower quartile is 2, so another bar. And upper quartile is 3.75, so here's 3.5, here's 3.75. We make a box, with the outsides being the quartiles, and there's our whisker. And what this says is, when you just go by numbers, not value of numbers, then 50% of your data is within this. 50% of your numbers are between 2 and 3.75. And this is 25%. Here's 25%. And together you get 100% of your data. Now I can do this on my calculator. So if I call up my TI, and if I look at I'll quit here and I'll show you what I did. I go Stat, Edit, so Enter, and I put in all my entries there. So if I go to list 1 here, so there's $2, $1, 2.5, 3.5, and so on. I go all the way down. I entered all the numbers. There's 20 of them. And then if I go Stat, arrow over to Calculate, one var stats means one variable statistics. And I go Enter, and I go second function 1, because there's an L1 there, which is list 1. That's where my data is. I go Enter. I get a lot of information here. X bar statistically is the average or mean, okay, which we didn't need for the 5-point summary. And this one right here is going to be valuable in a little bit. That's standard deviation. We'll talk about that later. This n means there's 20 terms. Min x is 1, which we know. Q1 is 2, which we know. Median, 2.5, we were right. Q3, upper quartile, is 3.75, and maximum 5.5. So that's a way to do it with your calculator. The interquartile range we talked about, if we go to the back page, is from here to here. Okay, so if we do upper quartile minus lower quartile, in other words 3.75 minus 2, which I have here, we get 1.75. So your interquartile range is 1.75. Now we talk about spread. Okay, we're talking about frequency charts, which gives us an idea, and they look a little bit like bar graphs or histograms. But what we want to do is, what we want to see is, how do they distribute? Now if you have, now this is a curve, it's called a normal curve, a bell curve, and if you look at this example below, I can pretty much say, if I kind of generalize, it looks like this. So it would look more like this line right here, which means it's normal. If you have more of the data on one side than another, then it's said to be skewed. All right, now I don't have there's no bar graphs here, but this one could look like this. Something like this, but then all of a sudden as you go to the right, you get less and less data, but there's still data there, but it really kind of strings out. This is said to be skewed to the right. This tail is the skew. So that's how you would say it's skewed. That data to the right pulls the normal curve and stretches it out like a tail. And this one is skewed left. So it pulls it that way. So in this example here, it's called a frequency chart. Instead of having the numbers listed out like this, it looks at it and organizes it and says, you know what, the number 80 shows up twice. 90 shows up 4 times, and so on. Then they make this chart. And this chart then is used to describe its distribution. Alright, so 80 shows up twice, 90 shows up 4 times, 100 shows up, let's see, 4, 5, 6, 7 times, and so on, and we get this distribution. And we would say it looks pretty much normal. Now here's our own example. We have all these numbers listed out, and if you put them in order, they would look like this. Okay, so a frequency chart would say that 22 shows up 1, 2, 3, 4 times. That should be right about there, no more. Then I would fill it in. I would say, okay, 24 shows up 1, 2, 3, 4, 5 times. So a little bit more. 25 shows up 1, 2, 3, 4 times. I'll go blue again here. 27 shows up 1, 2, 3 times. And I'll go red. And 29 shows up twice. Now, a lot of the data is in the middle here over 24. The right kind of tails it off a little bit. So the general curve looks like this. And that looks like it's slightly skewed to the right. The tail is your skew. Alright? Slightly. Not a lot, but slightly. And the next one here, I'll finish this one up. We have Again, distribution, but here they give us how many times it shows up. So 4 shows up once, and 5 shows up twice, okay, and 6 shows up 4 times, Seven shows up 8 times. Holy cow. That definitely looks like the mode, doesn't it? 8 shows up 5 times. 9 shows up once. And 10 shows up twice. Alright, so generally we're looking at something that goes up, then back down. Has a little space there, but it's somewhat normal. There's a little gap there, but there's still something there, so it's not empty, but it does kind of look like it's not very spread out to a tail, so it's slightly normal, somewhat normal. And this ends 5.3 Part A.